division multiple access. So CDMA is a scheme where multiple users can transmit simultaneously over the same communication channel. So in order to do this, a special coding scheme is used. In this scheme, each user is assigned a different spreading code. Okay, the spreading code is also known as a key or a spread signal. Now, each user's code needs to be orthogonal. So two codes are said to be orthogonal if the inner product is 0. So CDMA is a scheme where multiple users can transmit at the same time on the same frequency. And this is done because each user is assigned a special spreading code and all the codes are orthogonal. Let us take an example. We have two users, A and B, who want to transmit data. So each user needs to be assigned a unique spreading code or a key, and the keys need to be orthogonal to each other. So we have A's key and B's key. A's key is denoted by AK, B's key is denoted by BK. So A's key is 010011, B's key is 110101. Now A wants to send the data bit 1, B wants to send the data bit 0. So let A's data be represented by AD and B's data be represented by BD. Okay, so the information given in the problem is A and B are two senders. They want to transmit data. A wants to transmit a 1, B wants to transmit a 0, and each is assigned a key. Okay, both the keys are orthogonal. Now, when we begin solving this problem, first thing what we need to do is follow the bipolar notation. That is, each 0 is represented as a -1 and each 1 as a +1. So we follow this bipolar notation for the data as well as the key values. So A's key, if we follow bipolar notation, this 0 will be represented as -1, this 1 by a +1, this 0 by a -1, this 0 by a -1, these ones by +1. So this is A's key. Similarly, A's data, which is 1, will be represented as a +1. B's data, which is 0, is represented as a -1, and B's key will be +1, +1, -1, +1, -1, +1. So this is the first step representing each user's data and key in bipolar notation. That is, zeros are represented as -1 and 1 represented as +1. Okay, so now the next step is A wants to transmit its data. So it takes its data and multiplies it with its key. So AD is multiplied into AK. A's data is +1 multiplied by its key. So we take A's data and multiply by each bit of the key. So +1 into -1 is -1, +1 into +1 is +1, +1 into -1 is -1, +1 into +1 is +1, +1 into +1 is +1. So A's data is multiplied to each bit of A's key. So this -1 +1, -1, -1, +1, +1 is the data A transmits, so the signal A transmits. Now B does the same thing. B needs to transmit a 0. 0 is represented as a -1. So B takes that data, multiplies it with its key. So -1 into B's key. So -1 into +1 is -1. -1 into +1 is -1. -1 into -1 is +1. -1 into +1 is -1. -1 into -1 is +1. -1 into +1 is -1. Now, both these signals, as I said in CDMA, can be transmitted at the same time using the same frequency. Okay, this is possible because of these keys, these orthogonal codes. So at the receiver, if we assume that both the signals are received with the same strength, the following signal Z gets received at the receiver. So Z is AS plus BS. So the signal sent by A added to the signal sent by B. So bit by bit, let us add. -1 plus -1 is -2. +1 plus -1 is 0. -1 plus plus 1 is 0. Minus 1 you add to minus 1 is minus 2. Plus 1 you add to plus 1 is plus 2. Plus 1 you add to minus 1 is 0. So this Z is the data received at the receiver. Now at the receiver, what the receiver needs to do is retrieve the value transmitted by A and B. What were the bits transmitted by A and B? A had transmitted a 1, B had transmitted a 0. The receiver needs to detect that. So in order to detect that, what the receiver does is the signal it receives Z, it multiplies it with A's key in order to retrieve back A's data. So this is the signal it received, minus 2, 0, 0, minus 2, plus 2, 0. It multiplies it with A's key in order to get back A's data. So minus 2 into minus 1 is plus 2. 0 into plus 1 is 0. 0 into minus 1 is 0. Minus 2 into minus 1 is plus 2. Plus 2 into plus 1 is plus 2. 0 into plus 1 is 0. Add these values. It gives us a 6. Now looking at the result, okay, this result is much larger than 0. Okay, so what the receiver detects is that this user A had transmitted a 1, a binary 1. You have to look at this result and see if it is larger than 0. Since it is much larger than 0, the receiver has detected that A transmitted a 1. Now, in order to detect what the sender B had transmitted, the receiver needs to take Z, that is the received signal, and multiply it by B's key. So Z is minus 2, 0, 0, minus 2 plus 2, 0. We multiplied by B's key. So minus 2 into plus 1 is minus 2. 0 multiply anything is 0. 0 multiplied by anything is 0. Minus 2 into plus 1 is minus 2. Plus 2 into minus 1 is minus 2. 0 multiplied by plus 1 is 0. We add these values, it gives us minus 6. Since this value is negative, the receiver detects that B had transmitted a 0. So this is how the receiver has successfully detected that A transmitted a 1 and B transmitted a 0. So this process can be done for more than 2 users also. The same scheme where each user is assigned a code and every pair of codes needs to be orthogonal.